What is it about the fine-tuning of this universe that causes such energy, such controversy among scientists, philosophers, theologians? Everyone today is talking about fine-tuning. Why?
Well, it seems, and we don't completely understand why, that the laws of physics, laws of cosmology, laws of how the universe evolved, seem to be very special. Of course they're special. Everybody would expect them to be special, but they're special in a way that's unexpected. They seem to be special in the way that is just very, very conducive to our own existence.
To our own existence.
To our own existence.
Existence.
Laws of physics could have been very different. You could imagine a world that didn't have electrons in it. There's nothing wrong with that in the basic theory of the mathematical theory of physics. You could just throw away the electron. What would happen if you threw away the electron?
No chemistry.
No atoms.
No chemistry.
No biology.
No people to ask the question. We just wouldn't be here to ask the question. You could change the rules in other ways. You could make gravity stronger. Gravity is very, very weak. Normal people think gravity is very strong. When I wake up in the morning, especially the older I get, the harder it is to get out of bed. So I think, oh boy, wouldn't it be nice if there wasn't much gravity? Well, in fact, gravity really is very, very weak. If you were to compare in an atom,
The gravitational force between
Electrons.
and protons.
compared to the electrical force, the gravitational force is completely negligible. Why is gravity so much weaker than the other forces? Well, we don't really know, but here's what we do know. If it were just even a little bit stronger, stars would burn out too quickly, they wouldn't live long enough for life to evolve. Instead of stars, instead of galaxies, we'd have black holes. We can't live in a black hole. I mean, science fiction, maybe you can live in a black hole, but we can't really. Most likely the universe would expand and contract too rapidly. And so everything seems to be almost on a knife edge. That if you were to change the rules of physics, the laws of physics, even a little bit, the world as we know it wouldn't exist.
How many of these constants or laws of physics would fit into this category of fine-tuning?
The world, 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 as we know it wouldn't exist.
Category of fine-tuning where it has to be on a knife edge or close to that.
There's debate about that. There's debate about just how sharp the knife edge is for now almost everything. If you changed it very much, the electric charge of the electron, the mass of this or that particle, various constants of nature, how strong gravity is, If you changed it by a few percent, 10%, some of them 20%, some of them 30%, you would really be in trouble. The universe wouldn't look as it does.
Are we dealing with a couple of dozen? Are we dealing?
Yeah, we're dealing with a couple of dozen.
Yeah,
We're dealing
order
with
of
a couple of
magnitude.
dozen,
Order of magnitude.
with a couple of dozen
constants.
Order of magnitude of a couple of dozen constants. Order of magnitude of a couple of dozen constants. Order of magnitude of a couple of dozen constants.
Let's talk about
One of them, though, that has some particular strangeness to it, the so-called cosmological constant.
That's right. That's the one which is really okay. It is on such a narrow knife edge that it's almost inconceivable. If you were to change it just the tiniest bit, we couldn't be here. This cosmological constant is it's almost a kind of anti-gravity. It's a kind of repulsive force that's implicit in Einstein's equations for general relativity. It could be there. Physicists had every reason,
theoretical
reason,
not experimental reason, theoretical reason to think that the world should have this kind of anti-gravity. Anti-gravity would cause everything to
separate
at an enormous rate.
repulsion,
The actual magnitude of it is incredibly small. It is so tiny that the anti-gravity force is only felt on the largest possible scales in the universe. It takes an enormously large space and volume and time for the cosmological constant to create any real repulsion. This is not because the mathematics tells us that. This is just because for some unknown reason, this constant, whatever made the universe, I hate to say whoever made the universe, physicists have a habit of talking about
language.
whoever made the universe. They don't really mean it. But whoever made the universe made it with an incredibly small, tiny cosmological constant. It is so small that it is
Point.
zero.
We can sit here for a while. 123 of them.
And then a one.
And then a 1. I think
It's actually
But it is incredibly small, and nobody really knows why. The one thing that we do know is that if it were very much stronger, it would have blasted apart the galaxies. It would have prevented stars from forming. So you have to understand, galaxies and stars and planets formed because gravity pulled them together in the very early universe. This counteracting anti-gravity could have prevented that. Could have prevented the formation of stars, planets, and so forth. So if it were just a little bit bigger than this 0.000000, it would have prevented our existence. That is the sharpest part of this knife edge.
Okay, we have fine-tuning. We've got to deal with it. Now, there are a number of ways that we can explain that. I mean, it cries out for explanation.
Yes.
We cannot say, oh, yes, fine, let's go on. We have to explain it one way or another.
Basically, there are three explanations.
Okay, number one.
Okay.
Number two. that one I understand.
Right.
Accident.
Okay,
Right,
that
the
strains
picture-
credulity just
Right.
by on its
Strains
face
credulity.
value.
Right.
So it's an
Right.
accident just that way, and it happens to work out perfectly.
Right. 123 decimal places, zero. Not likely to be an accident. Well, there's a fourth way.
A third.
I didn't. Let me put the fourth way in before I get to the third.
Yeah.
The fourth way is, who knows? Maybe someday somebody will figure it out.
Oh, sure. There is one ultimate
Right.
solution. All of
Right.
these constants of
Right.
nature can be devolved
Maybe
down to
somebody will
to a
figure it out in the
fundamental
future.
equation that
Some
will
fundamental
express
equation.
all of these
Right.
as derived from.
But that would partly fall into the category of accident. You take some fundamental equation and you solve it. It would take an incredible accident for it to have a solution which was all that small. The last way, which physicists don't like, they don't like it because it runs against their ambitions. The ambition was to explain every constant, every number, to understand everything about the universe. The other way goes as follows. The universe is enormously big. We know that, incidentally. And when I say enormously big, I don't mean like we used to think 10 billion light years. I mean 10 to the 10 to the 10 to the 10th. We have no idea how big it is. Enormously big. We suspect that it is very much bigger than the region we can see. We also have reason to believe that it's diverse, that in different places it has different properties. There's good theoretical reason to believe that in some places maybe there is no electron. In other places gravity is stronger. And in some places this cosmological constant may be much bigger. The picture is that there's some very small fraction of the universe where the conditions just happen to be right for the existence of life. And it's not a surprise, that's where life is. It's more or less like asking, why do we by accident happen to live on a planet which happens to be at just the right temperature for liquid water to exist? That's a narrow range. Not as narrow, it's not as much of a knife edge as the cosmological constant. Why is that? Well, the answer is very simple. On planets where there can't be water, there can't be life. So it's true, a very small fraction of the planets in the universe are at the right temperature for water to exist. Where do we live? We live in the only place we can live, where water exists. Same kind of picture.
Universe very big,
Very diverse.
many different environments.
A huge slew of different possibilities.
And among these possibilities, in a few small pockets of the universe, conditions are right for life, and that's where life exists.
We live in the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We live in the only place, the only place we can live. We li
where water exists.
With planets, we know that there are large numbers of planets where a small number would be in the habitable zone where we have liquid water and the vast majority are not. We have that. With universes, we are relying upon theoretical ideas to say there are different bubble universes, pocket universes, inflation theory, chaotic internal inflation, creating different situations, each one of which has different laws. So we need to have that step.
That's right. We need not only to have a vast number of possibilities. Possibilities are like blueprints. Right? They're blueprints for different kinds of universes. I like to think of the possibilities as the possibilities analogous to the possibilities of life. DNA is the blueprint for life. DNA has a vast number of ways of being rearranged, and so there's a vast number of possibilities for life, but that in itself doesn't say that there are a vast number of living creatures around. It took something to make those blueprints into actual houses,
Right.
or whatever it happens to be. So part of the story is cosmological, that the expansion of the universe, what you called inflation of the universe, the very, very rapid expansion that took place at very, very early times, created a lot of quantum fluctuation. And that quantum fluctuation created patches of space with different properties. Those patches are sometimes called pocket universes, they're sometimes called bubble universes, but we live in one of them. That's the picture. That's the picture. There's mathematics that goes with it. And for those of us who believe in this particular picture of a tremendously diverse, some people call it a multiverse.
You like megaverse?
I like megaverse. And as I said in my book, the reason I like megaverse has nothing to do with any ideology. Multiverse just reminds me of multiplex cinemas, which I don't like. I like small movies.
We live in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in the only place, in the only place we can live. We live in
You've actually coined this term landscape
I did.
to describe.
I did, but there was a background, and the background comes from biology, the landscape of
Biological design.
and it means all the possible ways you could put
Be made.
together. It's a tremendously large number of possibilities describing life. Biologists have used the term landscape, and I was kind of borrowing it from biology. All the various possible ways you could put the elements of physics together to make different kinds of universes.
Different kinds of
Pocket.
universes.
So I did coin it in the context of physics, but as I said, it had a prehistory as the landscape in biology.
So the answer to the fine-tuning, as you would frame it, would be this landscape of possibilities populated.
Right. Populated by, how did I phrase it? Populated by a multiverse,
I'm sorry.
megaverse of actualities. But there is one element to it that's extremely important. Just as the number of ways that you can rearrange a DNA molecule is enormous. You have a DNA molecule with 1 billion base pairs in it.
The base pairs are the rungs of the ladder. You can rearrange them in a humongous number of ways.
And that's why there are so many different possibilities for life. It's important not only that the universe has this fluctuation which creates different environments, but it's important that the number of possibilities, the number of different blueprints is enormous. And that's where string theory came into it.
String theory.
Somewhat to the chagrin of those who invented it, produced,
Including yourself.
including myself, produced this huge number of possible ways of arranging its elements to create an enormous diversity of possibilities. This was not something that the string theorists had been looking for. They wanted to find a unique possibility for the universe which would be just like ours, and more or less by accident, just have the properties that life could exist in. That's not the way the theory evolved. The theory evolved instead to create this tremendously big number of possibilities, different ways of rearranging it, just like different ways of rearranging DNA produced an enormous number of ways of making a universe. Some very, very small fraction of those ways
would be conducive to the existence of life.
tremendously big number of possibilities. 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 As I think you're getting at, two things are necessary: a huge number of possibilities and a way of populating those possibilities to create environments of all different kinds.